So we are going to look into atoms and elements. Okay, so if you look at atoms, okay, what are atoms? Okay, atoms are smallest particles of matter, okay, that cannot be broken down, okay, by chemical means. Okay, so therefore, last time, okay, when we learned about solid, liquid, and gas, okay, we always look at the particles, okay, but these particles, okay, if you break it down and make it smaller and to the extent the smallest, yeah, the smallest, that is going to be atoms. Okay, but do remember, I also mentioned to you, okay, in the class, atoms, okay, even though they mentioned that you cannot break down atoms, okay, but the atoms also, they have subatomic particles, okay, subatomic particles, which is going to be what we are going to learn after this, okay, subatomic particles. It means even though you cannot break down them using chemical means, okay, but these atoms, okay, they have their smaller parts. It means they are smaller components over there. Yeah. So I have mentioned to you, okay, like for example, when you try to visualize atoms, you visualize atoms similar like to your soccer field. Okay, so if you have your soccer field over there, okay, and you have a small ping pong ball, yeah, that ping pong ball is going to be the nucleus, okay, the nucleus. And that inside the nucleus, okay, I already mentioned that they have proton and they have also neutron, okay, neutron. And outside, okay, we have many electrons, okay, they have many electrons. So this electron can be scattered throughout the soccer field. So you can see there's a lot of empty spaces over there. Of course, when we draw this, it's going to be difficult to draw in this manner. So they draw in a different way to represent the atom and the subatomic particles. We will look into that. Okay, but before we look into that, we need to also learn about what is meant by elements. So elements, okay, they contain only one kind of atom. Okay, so atom, we already know, is the simplest, okay, it's the simplest form of matter that cannot be broken down anymore. Yeah, so it cannot be broken down by chemical means. So if you have only one particular atom, for example, sodium, sodium is only made of sodium. Okay, which is going to be, if you look at your periodic table, it's going to be Na. So we call it as element. Okay, carbon. Okay, if you look at the picture, okay, carbon is an element because it's only carbon atoms. Okay, and sulfur, okay, is only going to be sulfur atoms. Actually, to be exact, sulfur, okay, each of the molecule of the sulfur, they have S8. Okay, but whatever it is, it's still element, same one kind of atom. Okay, so if you look at elements, okay, and we look at the periodic table, this periodic table, I took it from your textbook, yeah, but do remember, I want to highlight this again, okay, the periodic table that is inside your book is not the one that we will use for the exam. Yeah, please remember this. Your periodic table is going to be shown in the last somewhere here. Okay, I have attached over here. This is going to be the one that is provided during the exam. Okay, one thing that you want to take note over here is similar like in your textbook. Okay, they have written. Okay, they have written the bigger number below. Okay, and they have written the smaller number at the top. Like similar like what I told you about your classroom. Okay, they are going to label this classroom as Sec 2 courage, for example. Okay, that is labeling. And this labeling, they must tell, okay, this is the symbol, this is atomic number, this is atomic mass. Yeah. But one thing that you need to take note over here is, even though this is going to be the periodic table, they give you all these key. But when you write down, okay, boron, okay, you need to remember this. The smaller number, which is going to be the 5, supposed to be at the side and at the bottom, and the bigger number should be at the top. Yeah. So which is going to be 11.5. This is how we write. Okay, this is how we write. And this number 5 is going to represent number of proton. And number 11 is going to represent your nucleon number, okay? Or it is also going to be representing the mass number. So we have already learned about this, okay? But I just want to highlight, if you want to use the periodic table, please use this periodic table on top of your textbook. Don't use the textbook because, okay, if you look at this periodic table, I want you to take note of this particular part over here, okay, chlorine. Okay, this one is going to be given in your exam. Yeah, 35.5. Have a look over there. Yeah, 35.5 is going to be the mass of chlorine. Yeah, so if you look at your periodic table, okay, let's see whether it's the same or not. Yeah. Okay. Can you see here? It's written 35 only. So there is going to be maybe typo error or what? I'm not sure. Okay. But it should be 35.5. So do remember, there might be some difference with your textbook and the periodic table that we are going to use for the exam. But okay, if you have that confusion and so on, okay, please take note. I am not going to use the periodic table in the textbook. Yeah, it is just going to help us, yeah, to learn. Okay, but in your exam, this is not the periodic table that is going to be provided. So please take note of that. Yeah, but the arrangement and so on is going to be almost is going to be the same. Yeah, just the number, the values will be different. Okay, but okay, if you continue on that, okay, so if you have elements, okay, they are basically the same, okay, elements contain same kind of atom, okay, so if you look over here, okay, we have 118 known elements, okay, there are 118 known elements. And 94 from them, okay, are naturally occurring on Earth. And there are certain number, in this case, 18 plus 6, okay, that's going to be 24 elements, okay, they will be, basically they don't occur naturally. It must be synthetically made. Okay, but when you look at it over here, okay, we just need to know 118. Do you need to memorize this? Of course not. Yeah, even after some time also, I will forget about this number. Yeah, whatever we need, everything is in the periodic table. Yeah, so let's actually look at this. Okay, check for understanding. Yeah, so maybe I will call some of you. So what is an atom? Yeah, what is an atom? Terence, can you tell me what is an atom? Try. What is an atom? Terence, are you there? Max, what is an atom? Hurry up, hurry up. We're supposed to go very fast and suddenly now we are stopping. Yeah, hurry up. Yeah.
It's a particle of matter.
Okay, basically atom, okay, if you look over here, I already mentioned over here, it's the smallest particle of matter, yeah, which cannot be broken down, yeah. So please take note, yeah, atom is the smallest particle of matter that cannot be broken down by chemical means, yeah. So that is going to be the answer for the first one. So what is going to be an element? Okay, element is going to be, the element is made out, okay, from, okay, it's made from the same atoms. Okay, it is going to be consists of the same atoms, cannot be different atom. Yeah, that is element. How many elements occur naturally? See whether you remember this number or not. Michelle? Michelle C? You guys can hear me or not? Okay, or you guys are actually hearing Spotify or what? Kayla, can you tell me? Okay, how many elements?
94.
94. Okay. Oh, naturally, yes, correct. Yeah, 94. Okay. Okay, so you just can see 180 known elements, 94 occur naturally. So just directly, yeah. So 94. Okay, what is the periodic table? Okay, periodic table is going to be a table that consists all the elements, okay, that is found. Yeah, it is going to be systematically arranged. Yeah. So what is periodic table? Is a table that contains all the elements, okay, and with their proton number and the mass number. Okay, so if you write down table, okay, containing all the elements, okay, with their proton number and mass number or nuclear number. Okay, give names and symbols for three elements in group one. Okay, now what is group one? Okay, we have a look at this periodic table first. Okay, now if you look at the periodic table, okay, this is going to be group one, number one. Okay, you can see group number one. Okay, so group number one, you can see group number one, group number two, group number 3, 4, 5, 6, 7, and 8. Okay, that is group. Okay, and you can see period number one, period number two, period number 3, period number 4. Okay, quite simple. Yeah. So in that case, okay, if you look at period, okay, you can see hydrogen will come under period number one, helium will come under period number one. But hydrogen, okay, they do not come in any specific group. Yeah, they put it special. Yeah, they are not group one. Yeah, they are special. Okay, just please take note. Okay, but if I want to write down the electronic configuration, yeah, so I already taught you how to write the electronic configuration. Okay, like for example, boron, okay, if you look, beryllium, sorry, if you look over here, okay, beryllium, okay, when I write supposed to be 4 and 9, okay, so what does this number 4 means? Okay, this is going to be my proton number, okay, and this is going to be my nuclear number. Okay, number of proton must be the same as the number of electron. It means if you write down in form of PEN, number of proton is 4, number of electron is also 4, number of neutron, you find the difference, 9 minus 4 is 5. And if I want to write down the electronic configuration for beryllium, I will look at this value only, which is 4. You put 2, 2. Okay, remember the first shell must have maximum 2 electrons, then followed by 8, 8, 8, and so on. Okay, so you have 2 and 2. Now, if you look at this, okay, you can actually determine, okay, this one, the last electron over here, okay, it's going to be known as valence electron. Okay, valence electron. And this valence electron is going to be 2. And this is going to help us to determine which group that they fall into. Okay, it means that valence electron is 2, so they follow group number 2. Can you see group number 2? They are group number 2. And the number of shells, you see, shell number 1, shell number 2, okay? They are going to tell us about which period that they are going to be. 2 shells, therefore, period number 2. Okay, maybe some of you confused. Okay, let me actually go through this again. Yeah, so let's see. I'm going to select, for example, potassium. Okay, potassium. So when I write down in form of symbol, I will write down K, okay, and then 19 and 39. Okay, and if I write down PEN, okay, so let's actually call some people over here. Kimberly, can you tell me what is the number of proton, Kimberly?
19.
Okay, number of proton is going to be 19. So I will just write down 19 over there. Okay, we look over here. Now, Kimberly, can you tell me also electron and neutron? Electron, how many?
Also 19.
So 19 must be the same. How about the neutron?
20.
20. You find the difference, okay? 20. Now, from here, I want to write down the electronic configuration. It means we are going to look at this 19 over here. So maybe now, Naomi, can you actually help me to write down the electronic configuration? We will do it together. So, Naomi?
2.
2, okay, comma?
8.
Okay, now total is 10. Yeah. You need how many more? You need 9 more. So?
8. 1.
And 1. Very good. Now, from here, okay, can you tell me what is going to be, Gianna, can you tell me what is going to be the valence electron number? No, valence electron number. Valence is the last electron, yeah? So the valence electron number for this is going to be 1, yeah? So this is 1. Now, valence number is going to tell us about group number 1. Okay, we just follow that. And then Max, can you tell me how many shells that we have over here?
Sorry, how many what?
Shell. Just now I told you how many shell? 1, 2. Okay. So how many shells do we have over here? 1, 2, 3, and 4. Is that clear, Max? Okay. How many shell? Yeah. So 4. So this is going to be period number 4. Group, we look at the valence electron. Period, we look at the number of shells. Okay, number of shells. So now, okay, if you look at group number 1, you see potassium K is in group number 1. Okay, group number 1. And then we know it's going to be period number 4. Okay, 1, 2, 3, 4. Period number 4. Is that clear? Now, I just want to ask you another question. Okay. Silicon. Okay, silicon. Brian, can you tell me silicon? Okay, how many valence electron does silicon has? And how many shells that silicon have?
So the electron is for silicon is 14. So the first shell has 2 and then 8 and then
Okay, so basically you are just going the long way, yeah? So you have 14 electrons, so 2, 8, 4, okay? Okay, valence electron is 4. And then number of shells is going to be 3 shells, yeah? Okay, good. But you do not need to do that all the time. Okay, what you need to do is just by looking at this, okay, I'll save you some time over here. By just looking at this, you see 4 over here. This is group number 4. It means that silicon has 4 valence electrons. Okay, and silicon is going to be from period number 3. Okay, therefore, okay, they will have 3 shell. So you do not need to write it all the time. Okay, so let's actually try another one more. Yeah, so Jake, can you tell me, okay, how about bromine? Okay, bromine. How many, okay, Br, okay, what is going to be the valence electron, okay, and what is going to be the number of shell for Br? With bypassing, yeah, bypassing, rather than trying to write down the electronic configuration, just by looking at the group and period, okay, how you are going to say this, yeah, Jake?
The 7 for the...
Okay, group 7. So therefore, okay, this is group 7. So valence electron is 7. Shell?
3.
No. What is this?
I mean 4.
4, yeah. So 4. Okay. So what does this tell us? It means they have 4 shell, comma, comma, comma. And then the valence electron is 7. Okay. It means this one must be 2, 8, 7. Okay. So you can check, okay, because it's 35, okay, so you count, okay, electron, is it total 35 or not, okay? So in this case, okay, I don't think so it's 35 yet. 2, this is 4, okay, I don't think so it's 35 because this one I think going to become 18. It's okay, okay, forget about this, okay? This one is going to be not in your syllabus anymore, yeah, not yet, yeah, not yet, okay? So because you need to know up to 20 only, yeah, so BR is more than 20. Maybe last one, yeah, neon, okay, neon is going to be 10 and 20, okay? So maybe Cheryl, can you actually tell me how many proton, electron, and neutron over here?
14 electron, and also 14 proton and 14 neutron.
Neon, yeah?
Oh, sorry.
Neon.
10 electron, 10 proton, and 10 neutron.
Okay, good. Okay, so you have this. So if I want to just write the electronic configuration, so it's 2, Jesse, 2, what? Yeah, 2,8. Okay. So if you have 2,8, okay, Jesse, can you also tell me, okay, what is the valence electron? Hurry up, Jesse. Are you looking over here? I'm already circling here. The valence electron is 8. Yeah. So the valence electron is 8. Okay. So they will come under group number 8. Okay. Group number 8. And then you can see how many shell. Okay. 2. Okay. 2 shell. So it means that they will follow at period number 2. So if you look over here, group 8. Okay. You see group 8. And then period number 2. I just want you to remember this, yeah? So this one is done, okay? So if you carry on, okay, here, okay? Now, let's say, for example, okay, which element, I think this one, all this you can do, okay? Okay, I think this one also you can do. Water is not an element, explain why. Okay, now water is not an element, explain why. Okay, H2O. Okay, can someone tell me? Okay, maybe Jesselyn, can you tell me why water is not an element?
Because it contains more than one element.
Again, can you tell me again?
Because it contains more than one element.
Yes, correct. Okay, because rather than saying it element, it is made of different atoms. Okay, more than one atom. Yeah, not a different atom. Rather than saying more than one atom, it contains 2 different atoms. Okay, hydrogen, oxygen. Okay, it contains more than one atom. Okay, so therefore it's not an element. Okay, and then define a compound and define a mixture. Okay, what is a compound? What is a mixture? Okay, compound, okay, is a combination of elements. Okay, combination of elements, and they are bonded together chemically. Okay, they are bonded together chemically. Mixture, on the other hand, okay, you are going to mix elements. Okay, and they are not bonded chemically. Okay, they can be separated easily. Okay, I think they are related to this. I think I mentioned over here. Okay, so I will actually just go through here in a while. Okay, but anyways, okay, just to summarize what we have learned until now. Okay, we have learned about how to write. Okay, how to write the elements. You write the elements. Okay, in terms of, let's say, for example, carbon. Okay, if you have carbon, you write down, okay, from the periodic table, you will see, okay, carbon is going to be, they have written 12 and then they've written 6. Okay, whatever way that they write, okay, in your periodic table, okay, when we write it down, Okay, 6 will come over here and 12 will come at the top. Please remember that. Okay, and from here, okay, what we can say, this is your proton number, and the top is going to be your nuclear number, which is also going to be known as your mass number. Okay, and mass number contains basically the total, okay, of proton plus neutron. Okay, so proton plus neutron is going to be nuclear number. Okay, proton only, which is the same as electron. Okay, so that is going to be, we can know also, okay, number of electrons is the same as proton. Yeah, so and so on. Okay, but okay, the next part that I want to just mention, similar to the, I think, to answer the question that we had just now. Okay, compound, okay, is made of atoms of different elements bonded together. Okay, this is the answer for compound. And mixture contains different elements or compounds that are not bonded together. You can easily separate that. Okay, example, okay, bonded together. Example, carbon dioxide, okay, is a compound. Water is a compound. Okay, you can see different elements bonded together. Okay, but mixture, okay, is going to be a different element and compounds that are not bonded together. For example, okay, if you have water, okay, and then, okay, you put sand. Okay, so basically sand and water, they don't mix. Yeah, different compounds, different elements. Okay, and then you want to separate sand and water, you can use the filtration method. Yeah, easily be separated. So they are not, okay, bonded together. Okay, that is mixture. Okay, so that will answer the previous question. Okay, but now I will continue. Okay, we have learned that atoms, okay, just now I told you atom is the simplest simplest particle that cannot be divided to make it smaller by chemical mean. But I told you that atoms can exist in form of subatomic particles or subatomic smaller, yeah, much more smaller, which is going to be proton, neutron, and electron. Okay, what we need to know from there is going to be, we need to know about the mass and we need to know about the charge. So when it comes to mass, okay, proton, okay, generally the mass is going to be 1, okay, in comparison, yeah. So the proton is going to be 1. The mass of neutron is also going to be 1, okay. But for electron, okay, the mass, we take it as 0, okay. But I think because your worksheet is also going to mention certain things, I will just add over here. It's basically 1 divided by 1840, okay. It means the mass of electron is around 2,000, or you can put it like this. Proton is 2,000 times heavier than electron, okay? Or proton is 1,840 times heavier than electron. Neutron also is 1,840 times heavier than electron. Yeah, so that's why they put it as 0. And another thing that you need to note is charge. Okay, proton will have positive 1 charge. The charge for neutron, there is going to be no charge for neutron, 0. Okay. Electron, the charge is going to be -1, or okay, 1 negative. Okay, 1 negative. So that is going to be about proton, electron, and neutron. Now, let's actually look at how particles are arranged. Yeah, just now we already learned, okay, particles are going to be arranged. They are going to put it together, okay, in nucleus. Okay, the nucleus will contain proton and neutron at the center. Yeah, that is going to be the nucleus. And surrounding that, you are going to have shells. Okay, so electron shells. And the first shell can occupy 2 electrons followed by 8 and 8 and so on. So please take note. But if you do further reading over here, you can see that shells is going to be different energy level. Yeah, different energy level. So basically, shells can be also known as energy level. Okay, energy level. Another name for shell, okay, shell is equal to energy level. Okay, I just put down over here. So I put down also what is proton number. Proton number, okay, is going to show us the number of proton, but the number of proton is the same as number of electron in neutral molecule. And nuclear number is also known as the mass number, which is going to tell us about the proton plus neutron. Okay, because nucleon is the mass of the nucleus. Yeah, and generally it's going to be proton plus neutron. We don't include electron because electron, the mass is close to 0. Okay. And in your syllabus, you need to know about the first 20 elements. Okay. Anyone? Okay. Now, we need to know the first 20 elements in your periodic table. Yeah, so it is written over here. You can refer to the periodic table. You can refer to this table, doesn't matter. Okay, so you can just see what is the symbol that they use. Hydrogen, they use H. Helium, they use He. Lithium, they use Li. Beryllium, Be. No problem, yeah. Boron, B. Carbon C, nitrogen N, oxygen O, fluorine F, neon and E. Sodium only is different a bit. Okay, it's Na. Why is different? Because in Greek, they use sodium is natrium. Yeah, natrium. So they use Na. Okay, Na. So there's just maybe some changes here and there, but for sodium, you can memorize it's going to be Na. Maybe the only thing that may be different. Yeah. Magnesium Mg, easy to memorize. Aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium. You see, potassium is different. It's not Po. Yeah. It's not SO, okay, for sodium. Okay, why? Because they have other elements that they use SO also. So in this case, potassium, okay, similar in Greek, okay, they have potassium is kalium. Yeah, kalium. So kalium, okay, is actually they just follow K. Yeah, kalium. So maybe out of these first 20, yeah, you just need to be careful with sodium and potassium. Okay, let's actually check. Yeah, Max. Okay, sodium, how do you write the symbol? Sodium. What is the short form for sodium or the symbol for sodium? Why you guys still searching? Hurry up. Okay, it's just I just mentioned this a while ago. Naomi, sodium.
Na.
Good. This is what I want. Yeah. Sodium is Na. Okay. Potassium, Cheryl.
Okay.
Okay, simple as that. Okay, I don't want any delay. Yeah, immediately you must answer me. Yeah. So here, check for understanding part 2. You can see here, name the subatomic particles that make up the atom. So name is going to be you have proton, you have electron, and you have neutron. Quite simple. Okay, which subatomic particle has a positive charge? Positive charge. Proton. No charge. Neutron, almost no mass. Terrace, what is the one that do not have mass?
Electron.
Yes, good. Okay, electron. Okay, almost 0, which is 1/1840. Now, an atom has 9 proton. Okay, atom has 9 proton. Which element is this? This one we cannot just simply think and get the answer. You have to look at the periodic table. 9 proton. So this is 9. Yeah. So the answer is fluorine. Okay, so fluorine. Now, why do atoms have no overall charge? Okay, no overall charge because atoms have the same number of proton and the electron. That's why proton is +1, electron is -1. Generally, atoms have no overall charge because the number of proton and electron are the same. Yeah, please remember that. Now, define proton number is the number of proton. Defined nuclear number is going to be the total number of proton and neutron in the nucleus, or the number of proton and neutron in the of the atom. Yep. Give another term that can be used in place of proton number. Okay, another term for proton number is going to be atomic number. Okay, atomic number. Nuclear number, another term is going to be mass number. Okay, I hope this is clear. Periodic table gives element in order of what? You see the order, yeah? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I hope you get the idea, yeah? Jesse, in terms of what? The one that I think, what is that?
The first 20 and the first 18.
Yeah, first 18, which is actually that number represents what? Your atomic number, right? Or the proton number, yeah? So that number, okay, those number at the front, the one that I take is going to be your periodic table is arranged according to in order of proton number, okay, the number of proton, okay, how many proton they follow accordingly, okay, they arrange according to increasing number of protons. Okay, identify each atom and say how many protons, neutron, and electron. I think this one quite easy. Maybe we just do for these two, yeah. So oxygen, okay, PEN. How many proton? Okay, Max Leon, can you answer me now? You're muted, Max Leon. How many proton?
16.
Okay, proton is 8, yeah, please remember this. Okay, 8. Okay, and electron is going to be 8. Okay, and how many neutron, Max Leon?
16.
Not 16, come on. Yeah, the difference. Okay, neutron is 16 minus 8. Okay, which is going to be 8. Yeah, please take note of all this. Yeah, okay, by this time you should not be even struggling with this. Yeah, Naomi, can you tell me about the PEN over here? Okay, so proton for magnesium.
12, 12, and 12.
Okay, 12, 12, and then the difference is going to be 12. Good. So Max Leon, I want you to answer this for me now. Okay, PEN. Max Leon, proton.
13.
13, okay, good. How many like?
13.
Yeah, must be the same. How many neutron?
14.
Okay, very good already. Okay, okay, make sure you're focused. Yeah, Max Leon. Yeah. So now, sorry, not Max Leon. Yeah, Maximilian. Yeah. Am I correct? Yeah, sorry. Yeah, I confused with another person. Okay, anyway, okay, let's actually look, continue further. Okay, electronic configuration, we have done this. Yeah, so the first shell can only occupy or can only hold on to 2 electrons. It fills up first. Second electron, they can actually hold up to 8 electron. It fills next after the first shell. And the third shell can only hold 8 electrons. Okay. When it is the outer shell, yeah, the next 2 electrons will go into fourth shell and so on, yeah. This arrangement is called electronic configuration, and you can write it in this way, which is going to be 288, yeah, 288. So now, okay, if you look at, hold on. If you look at the first 20 elements in your periodic table, okay, if you try to draw that, okay, you can see they have the 1 electron over there, okay. They have 1 electron over there, okay. So we fill up 1, and then the second shell, okay, you have this. So you have this. First shell, 2 electrons. Then you need to go for the third electron. You must have the second shell, maximum 2, yeah, in the first shell. Then you keep on filling up, okay, fill up to 8, okay. So that's why it's going to be known as period number 2 tells us that it's going to be 2 shells. When you go to third period, now you have 3 shells. You see 1, 2, 3, 3 shells. Yep. And then group number 1, so 1 electron, 1 valence electron. Group number 2, 2 valence electron, okay, and so on. Okay, I hope you get the idea. Yeah. So, like for example, calcium is 2882. Okay, so how many shells that we have? 1, 2, 3, 4. You see, period number 4. Okay, so in total, I want you to remember this: number of shells is going to be shown by the period. And your valence electron, okay, number of valence electron is going to be shown by the group. Okay, this is what I want you to remember. Okay, now let's look at the patterns in the periodic table. I think we have certain things that you need to know. Yeah? The periodic period number tells you how many electron shells are occupied, like what I said just now. How many electron shells? If 4 means period number 4 means there are total of 4 shells. Okay. If you have group number is going to be the number of outer shell electrons. Okay, and they have total 8 groups. Yeah. So 1, 2, okay, 3, 4, 5, 6, 7, and 8. Okay. And okay, the number of the outer shell electron, okay, they tell us how the element reacts. It means that okay, all these group, yeah, if they follow within this one group, group number 1, they are going to react the same way. Okay, they are going to react the same way. And group 2, they are arranged like this. They have 2 valence electrons, so they are going to react same way also. Okay, and the same thing, group 3. The way that they react, okay, is going to be same. So we call it chemical property. Okay, the chemical property is the same. Why chemical property is same? Because in order to react chemically, you need electron. Okay, electron. So if you have the same valence electron, okay, like for example, 1 valence electron, 2 valence electron, and so on. If you have the same number of electrons, they will react chemically the same. Yeah. So I just want to know now, okay, Brian, can you tell me, can phosphorus and sulfur chemically, are they going to react the same?
No.
No. Yeah, they are not going to be chemically reacting the same. Okay, but Jesse, can bromine and iodine, are they going to be chemically the same? The way that they react, are they going to be chemically the same, Jesse? You're muted, Jesse.
Yes.
Okay, so yes, because they are going to be same group. Okay, same group because they have the same valence electron. They are going to be chemically the same. Yeah. Now I'll just move on. Okay. Now we have many groups like just now. Group 1, group 2, group 3, 4, 5, 6, 7, 8. Just ignore this one. This one is called transition elements. Yeah. And then that transition elements also, you can see some sort of ladder over here, like they actually follow like this. Now, why the ladder is important? Because it tells us that, okay, this is all are going to be considered to be metal. Okay, all these are metal. Okay, according to the ladder. Okay, all these are considered to be non-metal. Okay, I hope. Okay, non-metal. Okay, the ladder will help us to tell which one is metal, which one is non-metal. Yeah, so I will erase again, okay, so that we can actually see overall again. Okay, so which one is metal, which one non-metal? How do I know? Okay, I will know based on the ladder over here. Okay, this one from here, okay, from here like this, okay, all this, including this, they are all metals. Okay, they are metals. Whatever that is not okay within here, they are all considered to be non-metals. I hope it's clear. Okay, non-metals. Now, If you look over here, okay, out of this, okay, there is a one group which is going to be group 18, group A, okay. So we call that group as, okay, group A, okay, group A. Group A, okay, we are going to, if you look at the, like say for example, okay, neon 10, yeah, so neon is 10, so 2, 8. And if you look at argon, argon is 18. If I write down, it's 2, 8, 8. Okay, you can see same valence electron, yeah, 8, same group. Okay, but what you notice over there is the last shell, okay, the last shell is going to be complete with 8 electrons. Okay, complete with 8 electrons. So you have 2 electrons per shell, the last shell complete. If they are complete, it means that they do not need to react with anything. It's like they already have 100 marks. Okay, they do not need to have 1 mark additional anymore. Yeah, 100 is already very good. Yeah, so it means they have 8 electrons. They do not react with others. Okay, therefore, okay, we call them, okay, basically they are unreactive, okay, and because they are unreactive, we call them as noble gases, yeah, because all of them are gases, okay, so noble gases because they are unreactive, okay. Example, helium. Helium we used to fill up the balloons, yeah, so helium is a unreactive gas, okay, so it's also known as noble gas, okay. So until here, any questions, guys? Jesse, all okay? Okay, so okay, let's actually continue. Okay, now let's actually randomly pick up some questions here. So maybe this one and this one, yeah. The atoms of group 8 elements have a full outer shell of electron. How does this affect these elements? How? Because they are going to become unreactive. Okay, they are unreactive. Okay, they are not going to be able to receive electron, or they are not going to give out electrons, so they do not react. Okay, now the element krypton is going to be group 8, group 8 period number 4. Okay, which one describe the electronic configuration? Group 8 tells us about valence electron, so 8 valence electron. Period number 4 tells us 4 period, so period 1, period 2, period 3, period 4. Okay, so the answer is this one. Yep. Now, the next, okay, is going to be, okay, what can you say about the chemical reactivity of krypton? Okay, unreactive. Yeah, unreactive. Now, Jesse, what do you have after this?
Arts.
Arts, yeah. Okay. Now, related to isotopes, okay, I will continue next lesson. Okay, so we will actually continue next lesson. Okay, see you guys. Okay, that's it. Yeah, that's it from me. Okay, bye.